Oh my, that's new. Well, good morning, everybody. And as it said, we're recording this for CVARC's YouTube channel. This is our Saturday morning radio school. And today, Norm Campbell, AB6ET, is going to bring us from the beginning till now with Morse code usage. And turn it over to you, Norm.
Oh, well, thanks, Keith, and good morning to everyone. I'm glad to see everybody here. I've put a few items together, but everybody says, "How do we get from there to here?" And what are we doing now? So, just as a matter of interest, uh, I put a few things together that talk a little bit about telegraph, radio, CW, Morse code, and a little bit about operating. I'm going to have a discussion, go through a few things with you quickly, and then at the end, we'll let Adrian answer questions. But I'll show off, I'll show off a few historical artifacts that I have that actually still work and that I use from time to time also. So let's see if we can get started. I was practicing with Keith earlier. Let's see if it comes up. So is that there, Keith? Is that there? Keith, do you see that?
It's all perfect.
Yeah, but let's see if it moves.
Still on the arrow slide.
There. Okay,
There.
how's that?
You're good.
Go club page?
Yes.
Okay. All right, so here's the beginning. Okay, here we are here for the I can't get rid of that logo. It says the meeting is recorded. Is there a way to do that?
There isn't, but it won't show on the recording.
You have to click on agree or something like that, or continue. It'll go away. I just had that happen.
Oh, okay, continue. Okay, continue, yeah. Okay,
Thanks,
so anyway, Canal Valley Amateur Radio Club, that's us, AA6CV. We're getting ready for field day in a couple of days, and there will be, or about a month from now, and there will be stations on the air, and one of them will be CW, and many of them. So here we are, from then to now, Telegraph and Morse code. What's that all about? So many of you know Samuel Morse, FB, that's his middle initials, Finley Breeze from family name, Samuel F.B. Morse, born in 1791, died 1872. But he was living in Connecticut, New Haven, Connecticut, and he was a painter, portrait painter. He was trained at Yale, went to Europe many times, painted many famous photographs of or famous paintings of prominent people, and he was commissioned to go to Washington D.C. and paint a picture of Lafayette. Who Lafayette was one of the heroes of the American Revolution, and while there in 1825, his wife died, and he didn't know it. He got a letter saying, "Come home, your wife is very ill." He packed his bags and hit the road, and by the time he got there, she not only was dead, she was buried. He said, "There's got to be a better way." And he went back, finished his portrait in Washington, D.C., continued to paint, and was thinking about these things. He said, there's got to be some kind of communications. And he'd been to Europe. He'd been back and forth to Europe many times. And at this time, electricity was kind of new. Electromagnetism was new. There were a lot of things going on. There were some devices that were used for, many wires pointing needles at things. And anyway, so he thought about this for quite a while. He was already an inventor. He and his brother, in fact, developed a hand pump for fire engines. And he was also developed some kind of a stone cutting thing for marble. So he thinks. He's not the only one that needed communications, though. So at one time, years ago, these guys here, the Prussians, had this semaphore thing that would wigwag these various signals and send messages back and forth. We've had the heliograph. That even dates back to ancient Roman and Greek times. Flashing light. Semaphore flags, pretty common. Everybody knows about those. These signal flags, run them up the flagpole and send messages. But those are all line of sight and visual. So about 1836 or so, Morse is still thinking about some kind of communications. He meets up with Alfred Vail. Alfred Vail is also an inventor, and he develops, and he's also got a lot of money, so that helped too. So he develops this American Morse code and says, I think we can get this to work by putting some kind of electromagnets together and coming up with something. Like I said, many of these things had already been developed, but what Morse did was develop this single line. Is my mouse moving on that?
Mhm.
Yeah, okay. This single line telegraph system. And through the use of a repeater, he could get this to extend many, many miles. So you get maybe, because of resistance and voltage and all that sort of thing at the time, you get maybe 5-10 miles out of a signal. But through the use of a repeater and a new battery, it could move on and on and on. And that's what he did here. Repeater, 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 repeater. And he developed this system. So here's a repeater. It's just a relay, electromagnetic. Input goes here, it clicks this right here, sends a little, makes the contact here, and goes out there again. So he says, this is going to work, but I need money. So he goes to Congress, and he's got some friends there. He says, I need some money. I can develop this thing. And 1843, he gets some money. 1844, he's in Washington, D.C., and he's doing a demonstration of his Morse electromagnetic telegraph and sends a message to Baltimore. And everybody knows what this one is. It's, it'll come up here in a second. Anyway, he uses this device right here, which is a recording register. It scratches out marks on a piece of paper. Vail has invented this key. That's the Vail key. Here's a better look at it. This is the replica of the Vail key. Just make and break contact. And this is the message that he sends on that paper. What hath God wrought? And you can kind of see right in here these little scratches on the paper. And here's the translation. W-H-A-T, developed by that code that we just saw. H-A-T-H, and so on. So there's a big need, we've figured out, for communications, and we know why. Western expansion and gold in California, 1849. We need communications across the country. And the telegraph takes off like crazy because it's been proven now. Morse went on for many years fighting patents and didn't get the recognition that he thought he deserved, and probably rightly so, because there were so many competing telegraphs. But the Morse system was used in the United States and America, and it was also adopted in Europe. And eventually he does become recognized, and patents get straightened out. Anyway, but the East Coast and the West Coast need to communicate with one another because California is a big part of the country now. Statehood, 1849, gold, San Francisco, Sacramento going like crazy. And the telegraph is one way to do it. But in the meantime, they figure, oh, well, the Pony Express, we can ride these horses and get back and forth. It takes days for a message to get from one end of the country to the other. So in 1860 to about 1861, the Pony Express is in operation. And at the same time, the Transcontinental Telegraph is being laid right next to it. And as soon as the telegraph is in business, the Pony Express is out of business. So they were in business about a year and a half, and the telegraph took over. They were able to send messages back and forth that newspapers could be printed back and forth on either end. Information is going like crazy. All these news companies were saying, oh, I need press time, I need CW, or I need telegraph time. Well, this company here formed Associated Press, AP, with many of the local newspapers to all get the same information. So all these newspapers joined this organization called AP. That's where that comes from. Associated Press. They send that messages back and forth. Also, time is money and telegraph is money. So they also developed a lot of codes and abbreviations. Here's the Western Union 92 code right here. So one that's still familiar with us is 73, 88, 73, best regards, 88, love and kisses. But instead of sending this entire message, they could just send a code, 73. Well, we know what that means. You get a copy 73 on this end, write best wishes on the other end. And they also developed this thing called the Phillips Code. You could write an entire sentence, paragraph, or newspaper in these codes. As just an example of it, you would send KFT for conflict, KPT for complete, OT, owing to, and there were hundreds of these Phillips codes that were developed so that you could just send a few brief letters, translate them at the other end, and print a newspaper. So here's a Western Union telegram. Western Union was big business and cost a lot of money to send telegraph and telegram, but it was big business. And then, of course, 1861, the Civil War comes into play. And great need for communication on both sides, actually. And Civil War telegraph, there's thousands of miles, imagine this, thousands of miles of lines strung all across the eastern seaboard, the transcontinental telegraph, and all over the place. So here's a picture of the Civil War telegraph wire being laid, and there's very much like our field day, it's a Civil War field telegraph station. And 1866, Transatlantic Cable. This is a successful transatlantic cable. There had been a cable that went from England to France that worked out pretty well. About 1858, there was a transatlantic cable that lasted about 3 weeks and blew up, and it didn't fare too well. But this one, 1866, this transatlantic cable went well, and then there were some other cables laid along with that. 1869, after the Civil War, America needs to get together, and the Transcontinental Railroad is finally completed, 1869. Abraham Lincoln wanted it before that, but 1869, it's finally completed. Delayed a little due to the Civil War. And right along with the railroad is the telegraph, and there's the railroad and the telegraph going together, coast to coast, linked by by communications and also personal contact. Some of the equipment that was used at that time are these kind of things. Keys, sounders, these are brass levers. This is called the humpback brass lever. This type of equipment was used for many, many years and worked pretty well. A good operator could actually send 40, 50 words a minute, and that's by hand. This is what a central telegraph office looked like. Pretty busy. Equal opportunity, too. So a lot of women's in there, and man, they're very noisy, big places. But a little more local let's say at a train station or a local office, be more like this with some few operators, some sounders, keys, and smaller operation. So in later years, Morse was recognized, and he's still traveling back and forth to Europe, trying to get recognition for his invention here, which he finally got, and royalty started coming in. He was recognized by governments all across Europe, and he became pretty famous and respected gentleman in his older years. And he was quite a philanthropist, donated to his alma mater of Yale, and Vassar benefited from him. So he looks like a South American general with all those medals. He looks got a lot of awards and recognitions for that. And in 1871, a statue was erected in Central Park, New York Central Park. I haven't seen it. I imagine it's still there. A big bronze statue. 1872, he died. So he got the recognition in his later years, and that was good for him. He was quite influential in a few other areas too. I mean, the telegraph was one, but he was, like I said, a painter. He did some sculpting, but he was also interested in he met was it Frederick Daguerre, who made the daguerreotypes, and when he was in France, he took an interest in that, brought that interest back, and showed it to Matthew Brady, who then became a very famous photographer. So he had his hand in on a lot of things. So as telegraph was well established and working out very well, Jesse Bunnell, who was a Civil War telegraph operator, said there's got to be a better way, and he developed the steel lever key. So the steel lever key, around 1880 or so, made for very good but telegraph, because it wouldn't bend and warp, and it was easy to maintain. So he made a couple of different kinds, started his own country, developed this business, and made all kinds of telegraph equipment. Like he made, but a lot of people did. There are many telegraph operators, telegraph companies. But anyway, he made things like this: mainline sounders, regular sounder here, steel lever key there, key on board with had a key and a sounder on it. So he was very busy in that, and he was quite successful right up until even turn of the century, and with his own company, and then by the name of the company even later than that. So progress continued with telegraph. Very, very exciting time. Here's another. This is what a telegraph would look like, maybe in one of the offices. A sounder in a resonator has a box around it. On that swinging arm here, could be moved around, and then sometimes a tobacco tin would be placed in there to give that sounder a little different tone. Experienced operators said that's what a plug would do, and a plug would be a new operator, and they call them lids because of the lid on the can, and that's where we even get the word lid now. We call somebody a poor operator or not a good radio person, call them a lid. Well, that's where that comes from right there. Telegraph also the starting point for the ticker tape and even the teleprinter, because the teleprinter, or the ticker tape, you could just read right off the machine as it came out, and the teleprinter would do the same thing. You type in something and you could read it out at the other end, and telegraph had to be sounded out and then received. I was going to tell you about the telegraph operators. The original idea was something like this, with the paper tape, and they would make the little marks on the paper. But good operators could hear the ticks of the tape being punched or marked with a pen. They said, I don't need to look at this and translate it. I can start hearing it. And that's where these sounders came in, and they didn't need the paper. It was just a mechanical thing. It was just the sound. And that's what we do now with CW also. It's just the sound. We don't have to write it down or translate it or do anything. You just hear it and you know what it is. So around the turn of the century, things like this came into play. Semi-automatic key, which is called a bug. This one's a little later model, but around the turn of the century, these came into existence and made telegraph even faster. Semi-automatic because it would make automatic dits. And that's with this part here, a vibrating reed with a spring lever here and adjusted by this weight for the speed would go back and forth and make automatic dits. And then pressing on this side would just rub up against a contact and make manual DAWs. So you would hold it for the DAWs as many times as you need to. You da 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 da, or press on the opposite side lever, and it would make dits, did it, or did, or whatever you wanted until it ran out of spring power, which you only needed 5 or so good dits to make something work. Also, the keys had to be modified just a little bit, and you'll see this one here with a bug lip right here. And this wedge then would go, it's a 2-contact piece. Here's the 2 contacts. This would go to your bug. The wedge would slide in under there. The key would be bolted and mounted to the table, but bugs were kind of expensive, and usually the operators owned them themselves, so they would come in with their bug, take it out of the bug box, slide this wedge into the wedge lip here, use their bug, and when they were done, pull it out, take it home. But around this same time, what do you think was taking place? What turn of the century, what is going on in the country around then?
The radio.
Radio is one, and there's something else that's taking over also.
Telephone.
The telephone, exactly. So the telephone is starting to take a hit on telegraph. And so is radio with Guglielmo Marconi. And he was an Italian inventor, came to the United States and started doing some of these experiments with radio and wireless. And they are making big progress in that regard. Here's an earlier Marconi wireless experiment. Here's a Spark wireless station. Took a lot of equipment to make something like that work, but without wires, called it wireless. A lot of possibilities there. One is ships at sea, like the Titanic had a wireless station, and they were able to transmit their distress call. 1912. The Titanic also is famous for a few other things, and that is, at that time, radio stations on board ships were actually owned by the radio company. In this case, Marconi. Marconi Radio provided the radios and the operators. They were not ship's personnel. And so they also didn't have regular schedules. I mean, they worked all the time, but let's say it's dinner time, they pulled the plug and went to dinner. After the tragic of the Titanic in 1912, mandatory radio watches came into effect, 24-hour radio and this and that. There were also some arguments about, let's say, a Marconi operator talking to an operator of another company. And Marconi stations were all started with the letter M, like Titanic was MGY. That was the Titanic call sign. M for Marconi, GY for the Titanic. And let's say if some other radio station came on, they may not want to have a chat with them. So a few things came out of that tragedy. This is the Titanic wireless room, and I'm not sure if this is the actual Titanic itself or the Olympic, which is very similar. But anyway, that's what it looked like. And here's the Titanic key. This is not the actual key, but this is one from one of the other ships, or just like it. And of course, the station at that time was Spark. So see this piece right here? The big plate on the bottom of that to keep your hands from hitting 5,000 volts. I think they call this the guillotine key. So I think this would probably make the circuit. And then from here, you would tap out your message. But this is the kind of key that the Titanic had. And then many more inventions were coming right along. 1904, the Fleming valve diode, the 2-part, what we call tube, replaced the detectors in radios that were very primitive at that time. They were just little containers that had little metal shavings and had to be shaken up frequently. They were called coherers. And something like this, the Fleming valve diode as a detector, was a big improvement. And then shortly thereafter, there's the DeForest audio triode. And then all kinds of experimentation was taking place with radio. It was going very well. Here's a 1914 AM voice transmitter. You see the big tube there. Surprisingly enough, a lot of these radio, they were able to develop a lot of power out of these radio stations. Telegraph was still there, but it didn't have the same importance as it did in earlier years. Hams were also getting involved in this too, and hams were looking at things like these diode and triode tubes and coming up with things. They also had spark radios, and there were a lot of big experimentations going on at that time. You know who wanted to control all that? Of course, these guys. The Navy thought they owned the radio waves. So in WW1, here's these U.S. Navy dreadnoughts. Look at those big antennas up there on these ships. The Navy thought they owned the radio waves. They wanted those dumb hams out of there, and they made up some regulations in it wasn't the FCC then, but I think the Department of Commerce, whoever was regulating radio, said, "Oh, get those hams out of here. We want them off the airwaves." Well, that's about the time that they gave the hams those useless frequencies of 200 meters and down. You know, all those short waves, and keep them off the long waves where honest to goodness radio belonged. And so World War I, hams were off the air. And they didn't get back on the air until about 1920. Around, so here's a field radio, World War I. And, field telegraph, still very much in use. Commercial radios coming into play. Home radios are there. And so around the 1920s, the hams are back in business again. And this is the kind of setup that a ham would have. A good ham would have a big spark radio like that and be on the air again. And that continued on, and radios continued to improve. And now here takes us right up to WW2. Here's a B-29 radio operator. He is surrounded by electronic equipment. Also during that time, in between the wars, many inventions were created. AM radio, FM radio, television, super heterodyne radios, single sideband, all kinds of stuff was taking place, and many hams were involved in that, and many commercial interests too. WW2 then brought all of that stuff together, and much of this radio equipment was used in World War II, and then went surplus after the war. These kind of things like this were used frequently. The J37 Key, ubiquitous, it's everywhere. The Navy flameproof key, everywhere. The J38 Key, everywhere. And then, after the war, hams, we were able to buy up all this stuff. This is a more modern replication of an old radio station, but here's a BC348, the ART13, a couple of ARC 5s, all kinds of stuff. Here's some newer stuff like a 51J3 or 4 or something like that over here. Here's something even newer, R390. This stuff went up right into the 50s here and 60s. But hams were able to take advantage of this stuff and get on the air and make a lot of contacts. A lot of modern radios were in use at that time too, but still standard radios, CW, AM, single sideband was coming in at that time. And in innovations in CW were things like this. In the late 50s, the Hallicrafter's TO Keyer, designed after this guy, I think it was W8TO, I'm not sure, W6TO. Anyway, they called it the TO Keyer. It was a tube automatic keyer, which was quite an improvement over the hand keys. and the bug because it would make automatic dits and automatic DAWs. And wow, what a thing. Nowadays we have stuff like this, automatic keyers and code practice oscillators, very modern. And to make that automatic keyer work, you have to have something like this. You have to have some kind of a device that makes a contact on the DIT side and a contact on the DAW side. Then the unit itself makes the actual signal. So here's a single lever paddle keyer here, which is very similar to a bug, and they were easy to use, and some people still even prefer those. And then right below that, right here, is the double lever keyer paddle, and you could use it like this, like a single lever, and just make the contacts back and forth. But it also had the ability to squeeze, and it would either make A's, da 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 da, or N's, da 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 da, depending on how you had it set up. But they call that iambic A and B. And many of the combinations of letters would either use that da combination or that dit combination, whatever you got used to. And that was used with one of the automatic keyers. And these are automatic keyers right here, like the MFJ keyers out there, millions of those. There's plenty of other automatic keyers now. And so many of us now have radios that have keyers built in. So you would use this on either an older radio or, for practice, or for let's say a memory keyer that you'd take to some other thing like a field day. You'd set it up to send messages, and you could take it with you and then use it on whatever radio. And same with these code practice oscillators, little transistorized units. Plenty of those made. Everybody made those. You made them yourself, or you could buy one of these little Heathkit code practice oscillators. But where are we headed now? The sky's the limit. We're going to space. So from telegraph and the wired telegraph to the wireless and all the stuff we're doing now with computers, digital, you can't talk about it all. Computers, cell phones, internet, satellites, microwaves, telemetry. This is where we're headed. This is where we're going now. We started there. We're headed here. And just for an interest, these are the last times this stuff was used. The last wired telegraph was in India in 1970. Last Morse commercial and Coast Guard CW, 1999. And the last time even FCC required Morse for amateur licensing was 2007. So we're way beyond that. Why do we even do that now? We do it now for fun and skill and remembering our ham heritage. This is Samuel Morse in a picture by Matthew Brady, and he's standing with one of his early units that called it a recorder, very similar to that thing we saw before. That's where we are. That's what we've done. I'd like to show you a few historical artifacts right now. Any questions about anything here while we're getting things together? Okay. Yeah, David, go ahead. You're muted.
Can you hear me, Norm?
I can now. Go ahead.
I was thinking while you were talking about erecting the cross-country Morse code system, the telegraph system, where was all that wire coming from? That was a lot of wire. Was that steel wire or copper wire? Do you know?
That one was a copper wire. They used steel wire and copper wire, but that one I read up on. I have some pictures, but I didn't put them in the show. It was a cable of about 1 inch. It wasn't that big, but it had in the very center, it said stranded very pure copper, and around the outside of that it was steel and and fabric and gutta percha, which is rubber, and a bunch of stuff like that to make it.
But it was single conductor, right?
No, I think each one of those little wires was supposedly insulated. So.
Well, you mentioned that in the schematic that it was single wire.
Okay, that was for the telegraph, the single wire telegraph, not that transatlantic cable. No, the single wire telegraph was a wire.
The transcontinental wire, not the
The transcontinental wire. Yeah, that would be just a single wire. But that, I mean, they put up more than one wire, of course, you know. But what they called that was the single wire telegraph, because you only needed one wire and a ground, or two wires. And compared to those old, the ones in Europe and some other places where they had all kinds of wires, and one would energize and it would magnetize a little thing and it would spin around, another would energize and it would spin around, and very complicated systems. But this single wire, they call the single wire telegraph with the repeater system in there, is what made Morse famous and what made his telegraph system workable.
Must have been quite an industry just to produce the wire, though.
Oh yeah, the wire. I'm sure.
I think Pat's had his hand up too, Norm.
Okay, go ahead.
Yeah, Norm, I'm just curious about duplex operation. Do they have a switch to cut out the recorder at the site where the operator was transmitting, or did he just listen to himself and have his recorder record what he was sending as well as what everybody else was receiving or was sending to him?
You know, I've looked at some of those circuits. I've tried to figure all that out. I know that if you just have two units, one on each end, it's always on. It's always on. The battery would be connected. That's at a time when battery was acid and metal, and in order for them to work, you just couldn't turn them on from time to time. They always had to be operating. So they would leave the system on, and you had a shorting bar on your key. I'll show you one of those in a minute. And the system would always be on. And when you release that key, that thing would click on the other end. You go, oh, somebody's there. And then you and it go on the other end.
Yeah, but was it clicking on your end as well?
I think it was.
Okay, so you basically heard yourself talk.
I think so.
Because of I can see where they might have a switch and turn it off when I'm sending and then turn it back to receive. But
I know I've looked at some of that. I still haven't figured all that out yet. So
okay.
I can make it work. I can make two stations work.
Oh yeah.
but that's in the same room on the same tabletop.
Yeah.
So, well, let me just show you a couple of things here, and we look at some of this old equipment.
And while Norm's grabbing the first one, if you're in speaker view, you will see him full screen, but you can also right click on his picture and choose the word pin, and that way he will stay full screen for you.
This is a relay that was part of that system I was talking about. This is what made that work. So every 5-10 miles, because of the resistance and that, they'd put one of these relays. The relay would click, new battery system, and move on to the next one. This is what made that system work. So this is a simple relay, in on one side, out on the other, and has a small electromagnetic piece right here. It would make a little bit of noise, but not the same noise as a sounder. Here's a pretty standard hand key at the time. This is one of the steel levers, so you got to figure it's after 1880. I hope that's showing up. I use these from time to time, by the way. That's why I have these little clips on here. This is it's unmarked, but many companies made these, but it'd be similar to a bundle key. Here's that shorting bar I was telling you about. So you keep the circuit closed with that, or open it up like that. Here's a pretty standard sounder. This one I think is made by Bundle. So electrical contacts go in here. When it contacts and energizes, this little bar up here goes up and down. These are electromagnets here. And there's a magnetic bar across the top that pulls down.
So at that time, Norm, each element of a letter, a single dash or dot, you would hear two clicks for it, a start and an end click.
Right.
There wasn't
Yeah.
any kind of tone yet.
No tones on this because this was not CW. CW is a radio term, continuous wave, that is meant for on and off keying on a radio. Turn the radio on, turn the radio off, and that was the continuous wave. These waves here will actually fall off after a while because of the resistance and everything. That's why we use that repeater system with that relay business. But a radio system is CW, which is continuous wave, and it's a series of on and offs at always the same amplitude as it is sent. And then there's another tone that comes in your receiver that's mixed together, and that's what you hear. That's where the tone comes from. But on these sounders, here's another sounder. They just make that click. See, now these two sounders look the same, but you just heard them. They have a different sound to them. Oh, we did talk about the American Morse code. That was used in the U.S. because that's what the one Alfred Vail designed. But in Europe, when the Morse system was adopted, they changed it a little bit. They call it the International Morse code. So many U.S. operators had to know International Morse code and American Morse. We use now on our radios all International Morse code, but sometimes you hear holdovers from the old American Morse. And one would be like a zero. The zero for International Morse is 5 DAs. Da, 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 da. But American Morse is just one continuous hold down da. Sometimes you hear guys do that. Da. That would be a zero. Now here's something called, this is a bigger one. This is called the Mainline Sounder. And this one's really big and really heavy, and you can vary the tone with this little lever right here. See, there's an anvil on here. See this? And here, it's like ringing a bell. And so when this thing goes up and down, and you'll notice that the let's see, the bottom piece here is not right on the board. It's up from the board a little bit. Can you kind of see that? I hope that's showing. But anyway, so it rings like a bell. Every one of those would sound different. We talked about that key on the board. Well, here's one here. Here's a key on the board. So something like this could be either used as a training set where you just connect it up to a battery like I have done here from time to time. And you just tap the key and the sounder will sound. Or it might be used at home. These, some people had, telegraph right at home and say, oh, yeah, here, getting a message. I have to go to work today. But everything is handy. It's all right in one place. You wouldn't need a separate sounder and a separate key. It's all right there. So we talked about the bug. Now, here's a bug. This is a 1938 bug. Even now, they look about the same. You can still buy bugs. Here's what I was telling you about. Here's the vibrating reed right here, this piece here, and then the weight right there varies the speed by moving that up and down. Makes contact right here, and so the spring action would make this go dit, 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 dit. And then for the DAW side, you just tap on this right here, and it makes a contact right there. So you just hold that and go, da 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 da, as many times as needed. An operator would bring that with this. Actually, I borrowed this from Brad, who's not here, W6VO, but he got it from Phil. Is Phil here? I don't see him. K6UJO. I actually gave that to him, so I appreciate them letting me borrow it. But an operator would bring that to work with him in his bug box, open up his bug box, take his bug out, take his wedge. Here's the wedge I was telling you about. These two pieces of metal here separated by a small insulator inside. And you have two connectors here. This piece here is a string, so you tie it down so you don't pull your wire off. That would go to the contacts, two contacts on your bug. And then you would take your key. Now this is a Western Union key. You know it's after the turn of the century because it's got a bug lip on there. So anyway, you'd slide that wedge in between there. It makes contact, goes over to your bug. This would be bolted to the table. You use your bug, and when you're done, pull the wedge out, put it back in the box, and go home with it. This one may be a bundle, I'm not sure, but Western Union contracted with thousands of these. They're still available. They're still out there. This is what they call the champion key. They're everywhere out there, and it's a good key, still good. I use it all the time. When we talked about WW2 and some of the keys that were available then, here's the ubiquitous J37. Actually, this is a J37 key on the J43 base. They make a J44 and a J45 and all kinds of other different things. But anyway, instead of having a shorting bar on here, it's got a switch. And anyway, the J37 key everywhere. Still available. You can even find them brand new from time to time. This one's very clean. This is the J38. Everywhere. They were everywhere. I got this when I was first licensed and have had that ever since. This is my first key. First key that I ever had. Learned CW and practice on and everything like that. I used it all the time. And then, let's see if Zach recognizes this one. Here's the Navy Flameproof. And see, all the contacts and everything are totally sealed inside here. So that if you use this in a hazardous area, like inside of a plane, maybe with fuel and things like that, or on board ship where you don't know what kind of maybe chemicals are present or whatever. Anyway, it would not spark back and forth on the contacts as they make contact. So this is called the Navy Flameproof. A lot of people really like these because they have a pretty nice feel to them. And they call this piece here the Navy knob, just the way it was. And of course, in the old days, they had this big flange on there because you'd have thousands of volts right across the key. And if your hand slipped off there, you could really blast yourself. And then moving right along to some of the more modern stuff. See, here's a single lever Vibraplex paddle. I use this all the time. And I have the double lever here also for our iambic friends. I never could quite get the hang of that, but anyway, I just use it as simple left and right, automatic dits and does. And of course, you got to have stuff like this. You got to have your key or your electronic key, or take it with you. But our radios have it built in. Of course, this one's an MFJ type. Many kinds. You can make them yourself. I made one very similar to that TO keyer years ago out of tubes. And then here, of course, is the code practice oscillator. But you can make these real easy with even just one or two transistors. So a lot of that stuff is available. It's all out there. It's all there. I would recommend a few reference materials here. Here's one I told you about, 200 Meters and Down by Clinton DeSoto. Great history of radio and when the hams got kicked off the long waves and went to the short waves. They showed us 200 meters and down. Here's the this is the way used to teach code ARRL manual. But guess what? It's almost a complete exact reprint of the Army and Air Force manual of how to learn International Morse code. Well, ARRL said, well, that looks pretty good. So they did that. And then you need other things like this, like this is an old operating manual. Here's a 1947 amateur radio handbook. So you never outgrow your need for that kind of thing. There might be some more stuff around here, but I think that's probably enough for right now. Anybody have any other questions about anything or anything we should talk about? Okay. Oh, and Zach is showing something here. What's that? Show us, Zach. Yeah, see there, is that a steel lever key? Yeah, very good. Yeah, one of the old ones. You can hardly go wrong with these old oval base keys. They're still the same. I'm telling you, I use this all the time. This one probably dates back to the 1880s because it's the steel lever, so we know that. I use it many times.
Gary's got his hand up.
Gary.
Yeah, hey, can you hear me okay, Norm?
Yeah, go ahead.
Hey, Norm, you may have covered this, forgive me if you have, but when did single line telegraphy go multiplex? I had heard that there was an invention of sorts that now you could send several signals over the same wire.
I've seen that. I don't know exactly, but I know that for those things like the Transatlantic Cable and some of those things, they were doing that. So I'm sure it dates way back. I don't know exactly, and I've never been able to figure that out. I don't know how you can send two signals over the same line, but Zach knows because they do it on telephone all the time. But it dates way back.
Yeah, because I know that the big problem, of course, was if you had a single line and it was just single plex, you had to, an operator would send a signal down the wire and say, I'm here, here's my message.
Exactly.
Yeah, so it goes to my next question. I don't think you can answer it, but you see in the, excuse me, in the old movies where they connect into the telegraph wire, and if it's multiplex, I wondered, how do they pick out the right frequency or whatever they're sending?
I don't know.
Yeah, okay.
I don't know, but that was a big problem. Especially during the wars, for tapping into those lines, telephone, telegraph, all those things. So I don't know exactly how they did it.
Yeah, okay.
Yeah, I know in the telephone company, because it was voice, there's many different ways of multiplexing
over the same wire.
of same wire.
Yeah, but I had heard that they could do something on the order of 5 or 6 individual messages down at the same wire, and it wouldn't interfere with someone else, if that's correct.
Somehow.
Yeah.
I heard one funny story about, I think it was might have been the Mexican War, with chasing Pancho Villa around New Mexico or whatever. Maybe it was in WW1. I'm not sure, but it was around that same time. Radio was really new. And one of these army posts had telegraph, and they were, could communicate back and forth with their headquarters. And the commander was surrounded. And so he sent a message. I'm cut off. I have no communications. I can't send for help. And he's talking back and forth on the teletype, or on the telegraph. Anyway, what else? Who else has another question? Okay, well, thanks for letting me in here today. It's good to see you, everybody.
Thanks,
Thank you.
Norm. Yeah.
Great job.
Yeah.